Previously we studied the rate law expression. In rate law expression, you have studied that it is the mathematical expression which denotes the rate of reaction in terms of the molar concentration of the reactants, each raised to the power which may or may not be equal to the stoichiometric coefficient. You have also learned that these stoichiometric coefficients, these are determined, these coefficients which are raised powers in the rate law expression are determined experimentally. That is, you have studied that law of mass action is theoretical, whereas rate law expression is experimental based. Now, today we are going to another topic, that is the molecularity of the reaction. The molecularity of the reaction, what does it mean? So, first of all, I will tell you the basic collision theory. As per the collision theory, collision theory क्या बता रही है हमें? As per the collision theory, for a chemical reaction to occur, for a reaction to occur, for a chemical reaction, for a reaction to occur, the reacting molecules must collide. Reacting molecules must collide. Must collide. This is the basis of the collision theory. So, I will write here number of molecules, number of reacting species ये एटम भी हो सकते हैं, एटम्स, मॉलिक्यूल्स और आयन्स which collide simultaneously, to bring about a chemical reaction is called molecularity. I will underline the word here simultaneously. The number of reacting molecules which collide simultaneously, number of reacting species, atoms, molecules or ions which collide simultaneously to bring about the chemical reaction is known as molecularity. So I will give an example. For example, H2 decomposition of hydrogen peroxide gives H2O plus 1 half of O2. So this is the decomposition of hydrogen peroxide. Here you know that there is only decomposition of one molecule. So we say, as per this definition, so it is unimolecular. Now second I will write here that it is PCl5, phosphorus pentachloride, decomposition of phosphorus pentachloride. It gives phosphorus trichloride plus chlorine gas. So it is also the unimolecule. Exactly, you know it, unimolecular. Again, let ammonium nitride, decomposition of ammonium nitride. This is ammonium nitride. If it will decompose, it gives nitrogen gas plus water. So it is also unimolecular. So number of molecules which collide simultaneously to bring about a chemical reaction is the molecularity. Now this is the unimolecular. I will show another reaction. For example, this is the reaction. Tell me, this is the decomposition of hydrogen peroxide. This is decomposition of hydrogen iodide. It gives H2 plus I2. So here there are two molecules So accordingly it is bimolecular. Similarly, here it is NO plus O3 gives NO2 plus O2. There are two molecules, so it is bimolecule again. Similarly, we can say that reaction can be trimolecular. For example, so it is trimolecular. This is trimolecular reaction. So we can expect, on the basis of this, we can expect that reactions can be of higher molecularity. For example, we can expect the reactions in which the molecularity can be 4, 5 or so on. We can expect, for example, so we expect that the reactions can take place where molecularity can be 3. Molecularity can be 3. I will write it can be 3 or 4. But it has been observed, it is observed that reactions, those reactions of higher molecularity, I will say higher molecularity, that is having molecularity more than 3 are uncommon, or we can say they are rare. There are reactions from the definition of the molecularity. We can expect that there can be reactions which can have 3 molecules may collide, or we can expect 4 molecules can collide. But it has been observed that the reactions in which reactions of higher molecularity, that means which have 3 molecularity, that means where 3 molecules can collide, they are uncommon or they are rare. I will show you reaction. That means why they are rare. What is the reason? Reason behind this is simultaneous collision. I have underlined that word simultaneously in the definition. Simultaneous collision, what does it mean? It means if the molecularity is 3, that means if a reaction takes, it's shown by the chemical reaction, it is shown by there are 3 molecules are colliding. What does trimolecular collision means? What does it mean? Simultaneous collision means that third molecule, I will write it, third molecule must collide. Third molecule must collide with the two molecules when they are in collision process. This is the meaning of simultaneous collision. That if that we say trimolecular, in case of trimolecular reaction, it means that this third molecule must collide with the 2 molecules when they are already in collision, So that means third molecule must collide when the 2 molecules when they are collision. So such collisions, chances of such collisions are rare. They are rare. Chances of such collisions are rare. Such collisions do not take place. Such collisions are rare. So, on the basis of, we can say that these reactions, on the basis of when we say the chances of such collisions are rare, on the basis we can say, हम ये भी कह सकते हैं that these reactions can be slow. I will write first, they can be slow. हम ये कह सकते हैं जहां पर I have told you that